how to do that. Here, just a second. Let me see who that is.
Michael.
Oh, don't answer it. That's my husband. Okay.
Okay, so these are easy because it's just like if it slants up to...
Yeah, and it's strong if it's all together and moderate if it's not very. That makes sense.
Yeah, something with these ones too that I got wrong, because the TA, she always goes over the quizzes with me if I do them by myself first.
Yeah.
I have to like prove to her I tried. So, oh, in 21, something about these is that I'm looking at the homework quiz that we'll go over, but it says that if the correlation coefficient, which is the R, you'll just learn that, you guys, is positive, they both do the same thing. So when one variable decreases, the other one decreases. If it's ever a positive, then it always does the same. Whatever one variable is doing, it affects the other variable the same way, if it's a positive. If it's a negative, then it always affects the other variable different, like the opposite.
Okay.
Does that make sense? So just keep that in mind. I'm just looking at the homework assignment answer key here. So like this first one is linear moderate negative association. Do you guys understand why it's moderate, first of all?
Yes. Because it's scattered more?
It's scattered, but it's still going in that direction.
Right. But it's not a tight scatter.
Yes. And then it's a negative because it's going that opposite direction.
Yeah.
And then the next one is a strong linear, and it's a positive. So the positive is going from your right corner up, and it's very close together. Okay? And so that's why, and then that's why it's a positive and it's strong. This is also a linear. There's linear and non-linear. They'll show us a non-linear in a second. So this one is a moderate because there's a ton of information, but it's still going up that way and it's still positive. Next one is non-linear. It's bonkers. It has no direction. Number 5 is a linear moderate. So that would even be hard. Like, it's still going up.
Kind of weak a little bit, but it's still going up.
Yeah, I would, like, if that was on an exam, I'd have a hard time wanting to say if it was... Well, the answer's not asking if it's strong or weak. Like, I would put that as a weak, moderate, positive, not a strong.
Yeah.
Like, well, I guess it... Anyway, I'd choose probably weak. I'd get it wrong. This is a weak, linear. That'd even be hard. I'd almost want to call that a non-linear, but I guess because there's enough going up into that direction.
Yeah.
Okay. Okay. Let's see. I'm going to bring this up. Oh, I have to find it. Does anyone else have SPSS up yet?
Do we need it?
Yeah, for this next one on the homework assignment. And we should practice doing it.
Yeah, I did. It's not very hard.
No?
No, it's just plugging in things.
Okay.
There's no, like, you don't have to weigh a case. You don't have to do anything like that. You just really have to graph. Is it graph first and then scatter plot?
I think this one first. I think this question, I didn't look at it, but it might just be asking for just a
graph.
A scatter plot. Yeah, which all you do is go into the scatter plots. I'm just going into it. You guys go into so that we can at least do when we do need to do an analysis data view. Because in our next lesson, we have to actually cut and paste some stuff. You guys go on for a second if you want. I'm getting into it.
Are you going on your computer where you can share it?
Yeah.
Okay. We'll do that then. My only question, I feel like everything else is pretty simple except for the S of X, Y. Does that come out on SPSS?
Let me just look at my notes for a second.
That's the pivotal.
Yeah. when you yes, you don't actually have to find that x SSY R times SX. As far as in the homework or the homework quiz, I didn't need to do anything by hand with that.
It's all on SPSS.
Yeah, and I have to try to remember some stuff. I need to get.
It's R times SX times SY. But
Yes. But in the homework or in this, we don't. Is it Madison County?
Madison County real estate.
What are they asking for that one? Because if they're only asking for a scatter plot, I'm okay with skipping to where we actually have to do something.
It's asking for a scatter plot, and then it's describing the data displayed in the scatter plot, and compute your sample correlation coefficient R. So we need to have that.
Okay, we should do it then.
That one, though. The other one's the exact same.
The next one. Yeah, they probably just have us do like 2 questions of the exact same. I'm okay if we just do 1 question.
Okay.
Sounds good.
And then we'll just need to make sure in lesson 22 to do the same thing, because there's B's. There's a new thing called B naught and B slope.
Oh, those are easy. Don't worry about that.
Okay. Are they going to come up? Sometimes I have to like request it again. I'm doing the Madison County one.
Where are we at?
In our good meeting.
And the what?
We're doing the first problem in our homework.
All right, and I'm going to share my screen, and you guys tell me, let's see, what they're asking for, and I'll see if I can, from my notes, and we go through and we'll make a scatter plot, and then we'll find the correlation coefficient or something like that.
Okay, so it's asking you just to create and attach a scatter plot for the price of homes compared with the square footage.
Okay, so I think, should I just make a scatter plot first?
Yeah, I think you just go to that graphs and that legacy dialog and scatter plot. I think that's all we have to do right now.
Always do the simple, yeah, and then because with the tutor I did this first. So simple scatter, then define. Oh, okay, what am I doing?
You're doing the list price to square foot.
Is this the LA Saturn Windsor 06?
I'm doing Madison County.
What the heck? Where are you all at? Oh, there it is.
Number 8.
Okay, I don't need to title it, but in the video they said you can title stuff if you want. And she said, at least for this lesson, lesson 21, like it doesn't matter which you bring over and what it, if it's in Y or X.
Okay.
Okay, so what would you guys say this is?
I'd say it's moderate positive.
I would too.
It says it's a strong positive.
It's not
Really?
strong though.
Strong because of the outliers?
Are you guys? Oh,
It says
maybe.
answers will vary. One plausible answer is that it does appear to be linear with a strong positive association.
Okay.
I would have said moderate positive.
Yeah, because it's not strong. I'm sure it's fine.
Okay. So now we need
so
to
in the
find-
answer key it said either one.
Yeah.
Okay, now I'm going to go to, this is what you guys need to learn for finding the linear regression or the coefficient thing.
Okay.
Okay, so we go down to regression, then we go to linear. All right, then I'm going to go to, we're doing, what is the, oh, wait, I made notes on what the dependent is compared to the independent. Okay, so the dependent response is the response-dependent predicting. So the body length. And then the independent is what helps predict what they're asking for. Does that make sense, you guys? So the independent is the tool or the object or the source that is going to help us get our prediction. So I'm not looking at the question, what is it asking us to predict and what might be helping us to get that prediction? That is what determines what is independent and dependent.
It just says that compute the sample correlation coefficient R, and it's asking, let's see, data collected on homes for sale in Madison County as of January 2011. Information on the listing such as price, size of the home, and style were recorded. Use the data to answer questions 8 through 12. It doesn't really, it says the scatter plot was attached, a scatter plot of price of home compared to square footage.
I think we should do the list price as dependent, or
Is that what we're looking for? Because the dependent is what we're trying to predict.
I think so. That's what was in the first question.
Well, we can do this and then look at the answer and see if we got it right.
Do list price and then square footage.
Okay, and then let's see, I forgot. No, I don't need to do that. I do need to do one of these. Oh, so you have to go to save, and you have to go to unstandardized. You guys have to write that down. You have to go to save, do unstandardized, I'm pretty sure, okay, and then continue, and I think that's it. Okay, so this is, let's see, what are we looking for here?
R
Okay.
is 0.843.
0.8. Okay, I need to go down.
I see it, the moderate summary.
Oh, right here?
Mm-hmm. No, up.
Up under moderate summary. It says R equals 0.843.
It's the second rectangle.
Right here. Oh, okay. It's
And
tricky.
then
So, Marjorie, when you did the analyze and the correlate and then the bivariate, what was the other thing you said? You had to save it?
You had to go here,
regression.
here, boom. I go to save, click unstandardized in your predicted values. This is just, the tutor walked me through this.
All right. Okay. And then it says, compare your description of the scatter plot from question 9 with the value of R that has been computed. Was your description correct or incorrect? What was clarified by seeing the correlation coefficient? So if in answer question 9 you said the data appeared to show a strong positive correlation, that is supported by R because it is a positive number and it's close to 1.
Cool.
Okay.
So the closer it is to 1, the stronger it is?
Mm-hmm.
Yeah, either a negative one or a positive one.
Okay,
They're
now to compute the sample covariance, the SXY.
Is that good already? How do you compute SXY, Marjorie?
Is this one, I'm trying to see on the homework quizzes if because I know I watched a video on how to do that by hand, but do they give us numbers? Let's see.
Give us S.
Is it on this formula already on this sheet?
Scroll down.
No, like, I'm just looking over my notes from the taking the homework quizzes. Okay, maybe I need to look back at the homework. Let's see.
The answer from the question is exactly may be different. So you can find this on the software.
Mom, do you want some water?
No.
I put so much.
Go to
I can help pour this. Squeeze the cup a little bit, Claire, and pour it back in.
Go back to where you were with regression linear. And go to save. Is there a sample?
Is it asking for a sample?
It's asking for the sample covariance. That's what SXY stands for. Oh, it says create covariance statistics, right? On coefficient statistics.
Yeah, I'm trying to think what I did. I thought I did. Bring over variables.
Oh, right there it says covariance ratio on influence statistics. Click on that.
Okay, we can try it.
Is it anywhere there? Covariance.
No.
Isn't it the standard deviation and the mean?
What is the answer? What's
The
the
answer is 1,078,000.
a big number?
178,943,333.
Well, I don't think anything is on here for that.
We can go back ourselves and figure that one out, I think.
Yeah.
I'm like looking through the reading and I don't see anything, so I need to watch the videos.
Well, I watched the videos, and the guy, he did something on Excel, but like the TA didn't want me to do anything on Excel. So, I don't know. And I don't remember having to actually figure that out with her yesterday on the homework quizzes. So, I don't know. Let's go on to another.
Does it have an S? Is there a value on there for an SX or an SY?
No, not that I know of. Like, there are tricky things. Like, in the next lesson, let's see, regression slope.
SX is the mean or the standard deviation, and SY. No, SX is the mean confidence, and the SY is the standard deviation.
Because it's saying R times XY times SX is...
Y is the standard deviation?
Y is the standard deviation, and X is the mean confidence rating.
So what if, let me compute this real quick and I'll tell you guys. Can you scroll down to the mean and standard deviation? Oh, there it is. Right there. Okay. Where'd it go? Oh, that's it. Okay. So we're going to do, what would be good, 0.843 times 22806.
8036. 0.91.
0.91 times 136289.
0.992. Maybe. Yeah.
I did not get the same answer.
Okay, well, let's just make a note that none of us know how to do that, and we'll come back to it if we have to, but I don't know if it'll come up even in the group quiz or not.
Okay, well, we already know how to do everything else. Let's just hop on to the group quiz.
Okay, do you guys want to do the quiz or just go on to the homework for the, what's it called?
The next one?
Yeah, for 22, and then we'll just do both those quizzes.
Let's do this group quiz first while it's fresh in our minds.
Sounds good.
On to the next one.
Okay.
Okay.
We're doing the group meeting quiz for 21. Oh, I just feel like so many of these classes, and specifically this one, has been like, let me shove down your throat as much information as we can, because we're just nice like that. Does anyone else feel like that?
Yeah. I'm like, I think I could enjoy statistics if I could enjoy like the lesson for more than 3 days.
Yeah. It's crazy.
Okay. I'll read number 3. The correlation.
I'll go into the SPSS.
Okay.
Okay.
The correlation coefficient is used to quantify. What's it used to quantify?
I think it's the direction and strength of the linear relationship.
Direction. A correlation coefficient is used to qualify. I'm going to see if I have an actual.
Strength of the linear association.
Here, I have a definition. It says to determine strength and direction of linear relationship between two quantitative variables.
Okay, so C.
Mm-hmm.
So the direction of the linear. A lot of this stuff too is definition based, like we have to remember for our exam. She just said, remember, like write down specific definitions.
Okay.
If
Go ahead.
a correlation coefficient is negative, when one variable increases, that's when it would do opposite if it's a negative. So the other variables
Or
tend to
decreases.
decrease.
So A.
A, yes.
Yeah. Only when it's positive do they do the same thing. The effect of the outliers on the correlation coefficient is not significant. That's false.
Okay.
At least I think. At least I watched a video, and it can really change a lot when there's outliers.
Okay.
All right, I'm going to go into Old Faithful now.
Okay.
Here, I'll share my screen with you guys.
It's going to start raining, and I'm supposed to be moving.
So,
Gray skies are gonna clear up, Donna. Put on a happy face.
So in Florida, it rains every day at 3 o'clock, so I'm hoping it just goes.
So it just rains every day at 3 o'clock.
Eddie, ask your wife.
She did tell me that.
Every day, 3 o'clock, it rains.
You know exactly the time.
Yep.
You can have the iPad, but you got to do your Khan Academy or
is your
something.
wife from Florida, Eddie?
She served there.
Okay.
She served a
Then
really,
Con,
really,
do
really
your
crappy area, poor thing.
She did her entire chart this morning. Okay, tell me what to do, you guys. What is it asking?
It's asking for the
Go away.
coefficient.
Go
We're going
up.
to analyze.
I don't know. Go in my bedroom.
So you want to do the duration and weight. And we just need the correlation coefficient.
Wait a minute. Am I in Old Faithful? Are you guys? Oh,
Yes.
duration.
Duration.
My
Then
9-year-old's trying to do stuff. Okay. I'm just going to do this right now. There is another, there's a thing.
And put your correlation coefficient. And that would
Okay.
be R, so point.
is it 9.01 or 0.001?
0.91.
0.901. Okay.
Wait, are you guys looking at this R?
Yeah.
Yeah.
This is 0.901.
Okay. Is the direction and strength between weight and duration? Oh, so we have to do a scatter plot too, I guess.
But it's positive and strong because it's closest to 1, right?
Oh yeah.
You guys just want to do that?
Yeah, let's do that.
And we're saying it's positive and strong?
But we have to do the scatter plot because it's telling us to match it.
No, it's not. You're choosing the
Oh,
R.
okay.
So A is the first one, the -1. Or 1 is the first one.
1 is 1?
1 is 1.
Or let's call these over here ABC.
Okay, D is 2. No, wait.
The next
1 is D. 1 is D. So 1 is 4. And then 2 is A.
1. 0.9.
0 is C, I think.
The next one.
Yeah.
Okay, I'm just listening to you right now.
2,
0.6.
I would say is 3. B is 3.
We already have a 3. Is that
That's
okay to have
3.
another one?
I would say 6.
What? Hold on. What numbers are we using for what?
I don't know what we're doing.
-0.6 is for 6 or F.
What about my answers? Are these what you guys have been putting? I got a 4, a 1, a 3, then a 6.
3.
The first one is a 5.
Uh-oh.
The first one.
Yeah, because letter D or number 4 is
Well, whoa. I guess
Or-
I think we all have different. So my first one is R equals -1.
Yeah.
Oh yeah.
Mine's R equals 0.
Uh-oh.
Okay. So
Let's
R.
go. Okay. So number 1 looks like what to you on Marjorie? Okay, let's see if the scatter plots look the same.
Let me share my screen, and then we can use that to base.
Okay, the scatter plots look the same, I think. It's just the other stuff.
I have, so for R equals -1, I have that.
I don't see your screen.
No, this is Marjorie's screen.
Okay.
Okay, so for R equals -1, what do you think it is?
I think it's what you have. Your D.
4?
Yeah.
Okay. Then R equals 0.
R equals 0, I think that is your 3. Okay, so R equals 0, which is also my 3. Okay. And then R equals 1. Scroll up.
Is that D?
R equals 1 is her A.
A. Okay.
Okay.
R equals 1 is
Whoops.
A.
R
Okay.
equals 1. There.
And then R
That's
equals
negative.
95 is
That's 5.
number 2.
Number 2?
Yeah, because that's going positive. It's our number 2.
Why can't they all be the same? It's a group meeting quiz.
And the R equals -0.95, that's your number 5.
Yeah, we're doing positive, not negative.
There you go.
Eddie's just correcting me.
Oh, okay.
Thanks, Eddie.
Yeah, that's it, right?
Okay, let me look at Marjorie's again. Let's see. I have the R equals 0 is 3. Our pictures are the same, but they're different on the other side.
I think this is what's switched around.
So if the R equals -6, which one is that one?
That one's 6.
Oh, yes, okay. 6. Oh, is that
Oh, I
-6? 6. -1 is 4.
Right here.
-95 is 5.
Right.
1.
-1.
Or 5.
Okay.
Okay, I get it, you guys.
Did we get it?
We did.
Did everybody?
Yeah, number 7 was positive and strong, right?
Number 7 was, yes, positive and strong.
Okay.
All right. I'm going into, tell me which one it was, a math one?
Math.
Efficacy.
Efficacy.
All right, and you're just going to find the R value.
love working together. Okay, what am I doing? Confidence or gender and score? Read the
Score and confidence.
Yep, score and confidence. Look at you just move that mouse so quickly.
I bought a new one. Best Buy. Because the one that came with my computer was bunk. I bought a new keyboard and mouse, and I love it. It's beautiful. It works. Okay.
728.
0.728, yeah.
728. And we would say that that is positive and strong. Right?
Yeah, because
Yeah.
it's close to 1, I think.
All
I
right.
think so.
All right, let's.
Who's gonna? You guys
submit.
want me to, or you
I'll
can?
do it.
Okay.
Okay.
We got 100.
All right. We'll see if I did.
Yeah, let's see if that one was all screwy.
I got messed up because yesterday or on Monday, you guys, when we were meeting, I got a phone call from the dealership, and you guys were putting in all your answers. And then I started putting in my answers, and I was like half listening to you, half putting in my. Anyway, I got it messed up. I got 2 wrong, but I emailed the teacher, and she let me get them. So I was thankful.
Good.
Okay, let's go on to 22 then. Yeah, booyah, we got all this done.
I'm just going to continue the video, and we can just turn it in together for this lesson.
Okay, sounds good. And we can turn it off after we do the next quiz too, if you know what I mean.
Yeah. I do know.
I don't get it.
I don't want to say anything right now though. Okay, we're doing the group meeting quiz. Oh wait, are we doing some homework first?
We're doing the homework first.
Yes, we'll do homework, of course. Meeting together. Okay.
This has a lot of y in it.
Yes.
Got
Okay.
some s of x, y. Got some
Looking.
r, and then it's got some y.
Okay, something unit for every 1 unit.
This one I haven't even looked over yet. So.
Okay, so something to remember and that we need to learn for our definitions for these ones, and the TA said we need to know these, like their actual definitions, is that y is the response variable dependent on what is being predicted, where the x is the explanatory variable independent on what is being used to predict. Oh, just what I was saying before. We just have to remember, because now it really does depend on kind of what we put in x and what we put in y. We have to make sure they are correct.
Okay.
Cool.
And what's it for
Okay.
F? F is what?
F?
I don't know about f.
You said Y is the response variable.
Oh,
Depending on what is being predicted?
are you asking for y or x?
X. Is it?
X is the explanatory variable independent on what is being used to predict. And so x is what is being used to predict the y, which is the response variable dependent, if that helps. Okay. And then B equals, let's see, the y-intercept. All right, hopefully I can remember. I don't think I wrote down how to do this, because there's a new little, an additional SPSS thing.
So the formula is y equals mx plus b.
No, well, now we're working on linear regression.
Yeah, but like that, just algebraically, the formula is y equals mx plus b. So if you use that formula, you can find anything.
Yes, and I'm going to share my screen again. And then you guys, if you can see, let's see. Let's see. I don't know if you can. Have you guys gone over? I can't see my. Oh, because I'm on my screen. Why did I share? I'm gonna cancel. Okay. Let's see. Can you guys see this? The Y. It's really Y hat. My funky Y looks like the hat is connected to it, but it equals to something called B naught or B0 plus B1 times X. Okay, this is, I don't know exactly when and where we use this all the time, but this is our new formula for this lesson. And the B naught or the B0, whatever you want to call them, that is the y-intercept. And then the B1 is your slope. Because we kind of need to know, they might ask us questions like, what is the y-intercept? And you have to be able to distinguish what that is in the question.
Yeah. It's like the same thing. They just overcomplicate it.
Yes.
M equals slope and B equals the y-intercept and y equals mx plus b.
Yeah. All right. What is our, let's see. Our first thing is, you have encouraged, given the linear regression of this. Okay, so all we do with this is the actual, what is the y-intercept? You don't even have to do...
You don't have to do any math. So the y-intercept is 5.4.
Yeah.
Slope
and then
0.5.
Yeah. And then for the y, to actually get the y, then we just do the little math. You just do the 5.4 plus the 0.5 times the y, or the x, which is...
What's X?
I don't know.
X
Is 16. It says in the question 3.
X equals 16, yeah.
And so that's how you get your 13.4. Okay. I'll go into the SPSS and you guys start reading the question.
Sounds good.
Which one is it, you guys?
Body measurements corrected.
Okay. Go ahead, somebody, while I bring this up.
Okay, I'll read it. Researchers studying health body composition recorded various instruments or measurements of 252 male subjects. Height, weight, age, and other measurements were collected on each subject. Open and data file of body measurements corrected. For this exercise, we will look at the height of the subjects compared with the weight. Researchers want to predict the weight of a man given his height. Use the information to answer questions 4 through 8. If we consider the relationship between the height and weight of these men, which variable should go on the x-axis, the y-axis, and justify your answer?
Okay, which one would go in the y-axis? The y. Oh, go on.
I think weight.
Okay, because we have to find out what the dependent is.
I don't have the answer sheet pulled up. Let me pull it up.
X-axis is height. Sorry. X-axis is height.
Okay. So
Height,
weight
x-axis, and weight should be on the y.
I got it.
Yeah.
Okay, does this scatter plot look like the answer key?
Yeah.
Yep, it does.
All right, and then I'm assuming I do that.
So find the equation for the linear regression.
I remember what to do next for our this lesson.
Okay.
Okay, good. What is it asking for, though?
Linear regression. They want to know what the equation is, and the equation is y equals negative 206.596 plus 0.483x.
I don't know. Do
So
you want us to do something else in SPSS? What?
it wants you to find the equation of the line, and so you find that on SPSS.
I'm going to do this. All right, so this is a new thing to do that they introduced in this lesson, you guys. So you go, instead of regression this time, because we're doing the correlation coefficient, let's see. I went to correlation, I went to bivariant, and then all I bring over are the two variables. It doesn't matter which order to put them in. That's all I'm doing. Let's see. I don't need to do anything there. Okay, I think this is all I do. Perfect. Now, the correlation coefficient is the opposite of 1. It's just never this 1. So it's this 0.48 number, I think. Does anyone have a answer key? Like, is this is this what they're looking for?
For the correlation coefficients, we're not looking for correlation coefficients in this
Okay.
one.
Oh,
We're
sorry.
looking for the equation of the line.
The equation of the line. What's the answer? Like, I'm just wondering if there's anything I can do here on
We're looking for
SPSS.
the y-intercept and the slope.
Oh, well then all that is just those numbers, you guys. Like,
Yeah.
that's all those are. So, like, yeah, it's just the,
Where do you get those numbers, though? That's what I'm asking.
Yeah, where's the numbers come?
oh, wait. Okay, I don't know. Let's see. So this says regression used to predict the weight of the, what is the y and what is the, oh, well, let's look, let's see here. Oh, I may need to do something. I'm trying to remember. Oh, okay.
No.
It might be coming back to me. It's all
So
coming.
I know how to do it. So you got to analyze regression, then linear. You put in your dependent stuff, and then you go into statistics. You're going to click on estimates and model fit. Then you're going to click on continue. And then, yep, that should give you all the answers.
Did it?
Oh, I'm not doing it. I Googled it. So,
Oh,
go to
because
analyze regression.
okay, I'll do it. Good. She had me actually, what'd she do? She had me actually do something with these two in data, but I forgot. I'll do what you told me to do, and then we'll see if that works.
Okay.
Because I'm trying to remember what she had me do. Because I remember she had me actually highlight or do something with the actual weight and the data in this, but I forgot what to do. So tell me what you think Google says to do.
Okay, so Google says go to analyze, regression, then linear. Then you're going to pull over dependent and independent variables.
So what did we figure? The y was the height?
No, x is height and y is weight.
So y is the dependent and height is the independent. Okay?
Okay. And then you're going to go to statistics. And you're going to click on model fit and estimates.
Okay, those are both done.
Okay, then continue. And then you're going to look at the coefficients block. Okay.
Hmm.
All right. So, where's your coefficients block?
Oh, right here.
All right. So your slope will be the where is it? Your slope will be
It's a negative 206.
yes. I'm trying to find the
The slope is the head length b.
and then the
Y-intercept is the b constant.
is under it. Yeah.
So are those correct according to the answer key?
Yes.
Okay, I'm going to write that down for a second. So what did we do? We went to, and this is finding what, you guys? I'm not looking at the homework right now.
This is finding your
Fine.
linear regression, right?
Yeah.
Okay, so we just did the regular, we did regression, linear, and then once we went into that, we pulled over the independent and the dependent, and then you went into stats, and we made sure that the estimate was done, and the, what else? I think they were both
Fit.
model
Fit.
fit. They were both in. Okay, and so, and then what is the constant in my chart here? What is that on the, what are, for they're asking for?
Constant is your y-intercept.
Okay,
And then your height is your slope right under it.
slope. Got it. Is under constant. Cool. Thanks. That's faster than whatever. Yeah, that's good. Okay, the bivariant thing may come up. I forgot what we do that with, but we'll figure that out. All right, what's the next question?
It says interpret the slope and intercept of the regression line if appropriate. It is not appropriate to make an interpretation. Explain why not. So it says slope of an individual man's height was corrected by 1 inch. We expect that his height would increase by 5.48 pounds. Y-intercept is not interpretable. First of all, it is not possible for a man to lose. For a man whose height is 0, secondly, it does not make sense for the height to be negative. What? Okay. Oh. So it says, predict the weight of a man who is 76 inches tall in 2 ways.
In 2 different ways.
Oh, okay. So it's going to be...
That's your x?
No, 76 is the y, I think, isn't it? Or it... I don't know.
I'm going to see what they're talking about. Which one are you guys on now?
We're on 8.
Okay.
The other one who's 76. Okay.
Oh, they want us to be able to do it by hand and then with the software. I have forgotten what she had me do.
Yeah, 76 is your x.
Yeah, I got the same answer too.
Okay, so on, let's see, which one are we on right now? Body measurement?
We're on 8.
No, what's our SPSS they're having us do?
Oh, it's the same one from before, the body measurements.
Body measurement. I just have a lot up. I just wanted to see what I wanted to bring up. Let's see if this is... So is it showing on here or?
So you will do your y equals mx plus b. So or y equals bo plus b1 times x, which the bo, which is the intercept, is your
okay.
negative 206.596.
596, and then this one is your.
Yeah.
Your
That's
B1.
your slope, or your BO, or sorry,
Yeah.
B1.
B1.
And you multiply that times the
The X.
of 76. Is that what it was?
Yeah, 76. Yep. That's good.
Okay.
I think we can do the quiz. Unless
Okay.
we do more stuff.
No, there's something we do at some point, and I have forgotten when we do something with this thing called bivariant and stuff like that. That's. Oh, I'll
Right.
bring these over in this. This is like, oh, this is the coefficient. That's just what she was helping us. That's one way to find. It's either here or right there. Okay, never mind.
Okay.
Got it both ways. All right. Yeah, let's do this.
Quiz?
Group quiz.
No.
Oh, whoops, I haven't done it yet. My computer completely died also when I was doing the exam. It was awesome. And luckily I'd pushed saved on most of my answers.
Mhm.
It didn't bring up the ones I didn't save. Okay, so given the math self, did we already have this one up? Math self-efficiency?
Efficacy?
Efficacy, yes, thank you.
Might be different. Well, if it's not.
I mean, just bring it up if someone wants to start reading.
No. All right, I'll read. Given the line regression in the equation, what is the y-intercept? It is 2.0.
And then the next one is what is the slope? And that would be 1.5.
Yep. Given the regression, what is the predicted y value of x equals 16? So it is -3 plus 0.25 times 16. I got 1.
Yeah, me too.
Wait a minute, are you guys doing the math for it?
Yeah.
Oh, I didn't. Oh no, -3.0 plus 0.25 times 16.
Yeah.
I got 14.4.
I got 1.
Parentheses?
Wait, I didn't do parentheses around anything. Eddie, what did you get for -3.0 plus 0.25 times 16?
I got 1.
Oh, what did I don't
Yeah,
know.
because you could put 0.25 times 16 and then just add on -3.
Yeah.
Okay, that makes sense. Okay, so am I still sharing with you guys?
You are.
Yeah.
Keep doing that.
Okay, now we're doing the math, right?
Mm-hmm.
Okay.
Guys, I just got my wedding pictures.
Oh, I love it.
Hey.
I need to do a scatter plot first, correct, you guys?
Yes.
Yes, you do, yeah.
I
And
want
what
to see
am I-
one of your pictures, Catherine.
Let's do it after this. Oh, I'm not looking.
Where?
What am I putting in the y-axis, you guys?
The package.
Um,
I have no idea. I'm not even paying attention.
The woman who takes 2 hours and still gets a B.
right.
An 80.1.
That's awesome. That's amazing. My grade point dropped 5 points because I did so poorly. Anyway. Okay. What am I putting in the y-axis, you guys?
So you're doing explanatory variable and score. as a response. So use confidence data for the explanatory variable and score for the response variable.
The response is the y then. What did you say? Score?
Response is score, yes.
Okay.
The y, is that independent?
Well, why didn't it do it? Let's see.
Oh, just kidding, never mind.
Where did it go? Oh, it's behind it. Okay.
So
All
is
right.
it like a hot dog, a hamburger, or a banana?
This is moderate positive, you guys, right here.
But they want to know what it's shaped like.
It is shaped like a hot dog.
I don't know.
It doesn't curve, so it's not a banana.
in there.
Not banana. The burger is more like a circle shape.
Yeah, a burger would be like non-linear.
What
Unless
about a
you
banana?
The banana would curve.
What's your other option?
a hot dog.
This is a hot dog, you guys. It's fat. It's got a bun.
It's got a booty. It's got
I don't know. If it's a banana, it could be opened and the peels are on the bottom.
Shut up. No, it's not even curving, Eddie. It's totally, I think it's a hot dog, you guys.
Okay, hot dog. We'll try that one.
Okay, just a second. I'm putting it in here so I don't get behind again.
Okay, based on the shape of the scatter plot you produced in the last question, what can you say about the appropriateness of using simple linear regression to model these data?
Okay, so we're saying it's a linear, moderate, positive. What are their options here?
Simple linear regression is appropriate for this data. If simple linear regression is used for this data, the results will not be reliable, or simple linear regression is not appropriate. I would put appropriate because it...
I'd say A.
Me too.
Yeah, let's go with that for right now.
Think that's appropriate?
I mean, it's not inappropriate. Right?
How many observations are in the data?
I don't know.
Many.
Way up here. I don't know. It doesn't say like any in the questions, does it? Or
How many observations are in the data? Oh,
Yeah, go back to the data.
it's open?
just a second. I have to find it. Are we on math efficacy?
Yeah, we're still on that one, I think.
Okay. So what is it asking for?
Observations.
How many observations?
How do we know that? Like,
We'll scroll down. We'll say how...
Tell you if you do the R thing, the regression.
oh, do you guys think that's it?
It might.
Or is it asking for the R?
No,
What is it?
how many observations are in the data? And I don't know if it's just a simple 139 that was on your this.
If it's not on the R, I'd say 139.
The R says 0.728.
I don't think that's right because there's more
What's
than
that?
that.
It has an observations thing on it?
I think 139 is your bottom right one. On the end?
Right here?
Yeah, I think that's what your stand. It's like your sample. That would be. I don't know.
Oh, yeah, do 139.
Let's try that.
We'll learn a lot if we get all these wrong. I mean, we'll learn that we don't know what we're talking about.
What is the y-intercept?
Oh,
That's,
it's the coefficient thing on the bottom of your SPSS.
just a second. Coefficient.
So the x-intercept is
Oh,
is
right
that
here?
Yeah, 18.
Y-intercept.
Yeah, the
Yeah.
y-intercept.
So the
That's
y-intercept is first, is the constant. So 18. Okay, I'm just going to leave this up. You guys put the numbers in and then tell me the numbers when I go back.
Is it 18.690?
Yes, and then the other one is 12.695.
Okay.
12.695.
You guys tell me those numbers. What was the y-intercept?
18.690.
And the slope?
The slope was 12.695.
Okay.
So what is the predicted value of y when x is 4? So that's where we have to do some math.
So do we, we use these two numbers and do the math.
So it's 18.690 plus 12.695 times 4?
Yeah.
Is that what it is? Okay.
Yeah, it's just plus and then times.
I got 69.47.
Me too.
Yes. I got the same as you guys.
69.47?
Yep.
947. Oh, I need a dot. I need a period.
4 more to go.
Yay.
And my clouds are gone.
Hey, it might not rain today.
No, it did. It rained.
It goes, it comes in
You
pretty
had some
quick.
thunder. Yes.
Question on the scale of 1 to 6. What is the maximum predicted value of y? What the heck? And for these values of x, because there is a positive correlation, we use the largest xy to find the largest predicted y. Because it's a positive, so they react the same to each other. But I don't even know what they're asking for to do, you guys.
What is the maximum predicted value of y for these values of x? So I think it's just what is the biggest number on the scatter plot, right?
Like,
That's what I would say.
Does it say a
What is-
maximum?
There
It
it
says
is.
maximum. It's
Maximum
94.859 or something like that. That's it.
which number?
The
Way
very
at the bottom.
Yeah.
In the residuals?
hmm
Which
What is
number?
it? It's on it says 94 point.
Oh, I wish I could highlight. Okay,
predicted values.
94.8590.
Yeah, that's it.
Okay,
All right, let's
what's this? What is it? 94.85.
8590, or just 9, I guess.
9.
Okay.
94.859. Okay.
You guys tell me the number again, 94.859.
Yeah.
Yep.
Okay.
How many explanatory independent variables are present in simple linear regression?
Is that just,
More than 2, 1, or 2? And is it?
How many explanatory independent? Is there an independent thing on your SPSS?
independent? I don't
Oh,
know,
it's
but
just-
tell me what the variables I was working with again, the score and the confidence.
Yeah.
Let's see if this does anything.
I think it's just one, right?
I think it's just one.
I think so too, because this number right here, this 0.728, is our confidence correlation, and anyway, let's just go with 1.
Yeah, let's do one.
And then how many response-dependent variables are present in simple linear regression?
What the heck?
There's an
One.
independent and dependent.
Because there's one independent and there's one dependent, right?
Yeah.
We can try it. We're kind of BSing, I think, way through this, but let's just go for it. We'll see if we're wrong. I mean, we're going to have to try to figure it out if we're wrong.
Okay, number 15. A company in South Dakota manufactures hard hats used in the mining industry. They record measurements on all the hats they produce for quality control and planning purposes. The measurements they collect include hat size, circumference of the hat, the length of the major and minor axis, meaning the company wants to predict size of hat given the circumference. What is response variable?
So the response variable is the y.
Yes, because that's what we're trying to predict.
So we're trying to predict the size of the hat.
Hat size.
The size of hat because it is a variable being predicted.
Yes.
So A?
Because
think
it
it's
is the variable being predicted, yes. Because we don't want what is helping to predict. We want the actual thing being predicted.
Okay.
All right.
You want me to submit this?
Go ahead.
We got 100%.
Really? Good, guys. We're so smart.
Awesome.
my God. Oh, I got one wrong. Wait,
What?
you guys.
I
I
got
have to retake it.
Okay.
I got one wrong. Just a second. Yes, I want to retake it before you know what. And then, what number was this? 22?
Yeah. I'm gonna end the live
Please do.
now.
Okay.